So I'm going to record this and in exercise number 5, where we have parabolas, they definitely open down because the negative in front of the x squared term. So if I take a look at the problem with negative 2x squared, which is like a skinny parabola that opens downwards, then with a minus, with adding 1 to this, I'm going to have to shift this here, but the parabola is still going to be opening down because the negative in front of the x squared. Exercise number 18. Thank you for refreshing my memory. So let's see how this is going to be done. So in exercise number 18, we have parabola that opens upwards, right? Why is it opening up? Because the x squared with a plus sign. So in the previous example, I had a negative 2, but now we have a parabola that opens up. And I believe I asked you to find the intersections with x-axis, right? So it was a x squared minus 6x and plus 5 that we're supposed to factor. And then once you factor this, set factors equal to 0. So if you factor first term and last term, factors will be x, and then 1 and 5. And with these, the signs both are minuses. So we're gonna say that x minus 1 is equal to 0, or the other factor, x minus 5. And then we're gonna write that x is either 1 or 5. So now I think I recall. So I asked you to find the intersections with x-axis of this parabola. And now, so that was for the quiz. And now they actually asking in this exercise to graph. That's not what I was asking you to do for a quiz, because you wouldn't be able to put this in the chat, this answer, but you could now plot points 1 and 5 on the x-axis, their intersections with x-axis, and then connect them with a parabola that opens upwards, because we have a x squared here positive. So our function is x to the second minus 6x and plus 5. And also I can notice that this number at the end, I'm talking about that positive 5, is actually going to give us another important point here. I'm trying to write 5, hard time to write it, which is a intersection point with y-axis. So this 5 is going to be here on the y-axis. That's a so-called y-axis intercept. So always when we have a so-called free term, whatever it is, it's a intersection with the y-axis. And that's good to know. So what else isn't here? How about if we look at another graph, like problem number 27, that says, what if we try to graph equation which is y is equal to minus 2 divided by x? Well, it turns out this comes from the family of graphs of so-called hyperbolas, so 1 over x, right? Since I have a negative sign in front of this, the picture will reflect through x-axis. So the graph is actually going to be a pair of these pink branches of so-called hyperbola if you put a negative in front of it. One can say, so what happens when you multiply it by 2? So what if you have a minus 2 times that? Well, the graph will go away from my axis. In other words, if you take the x-axis here and put the branches of this parabola just like we already had, then the distance from x-axis now should be twice bigger. So it was down below here. So now it's like twice bigger. But that's not really changing the shape of our curve. So it's really pretty much the same thing. Same thing. So multiplying by some number, you can't really very details to see what's happening with the graph. So there are some more graphs in here, like problem number 35. So let me try to graph that one. Looks like that's a fractional function, but not really. Because if you look at problem number 35 and its numerator, you'll notice that it could be factored with x minus 1 times x plus 1, right? Because if you multiply x minus 1 with x plus 1, what you're going to have is a multiplication of first terms, which will give you x squared, multiplication of the last terms, minus and plus 1, that will give you minus 1. And if you see what's inside on the outside, where there be plus 1 and minus 1, so they will cancel each other out. So it's so-called factoring of difference of two perfect squares. And it looks like I can cancel these. So what we're gonna be left with is just a equation of x plus 1. So there is no denominator here because it cancels. And that's actually pretty nice, right? Because we have here the equation of line. And if I want to graph that line, what I need is just to have a pair of points. Some people usually like to use 0 and 1 instead of x for convenience. So if I try 0 for x and then 1 for x, then when I plug 0 instead of x, I'll be getting 1, right, instead of y. And when I replace x with 1, then 1 plus 1 will give us 2. So I can plot those 2 points. One of them will be exactly on y-axis at point 1, and the other with coordinates 1 and 2 will be the second point, and then connect them with a line. Will produce a graph of x plus 1. But that's not what we were asked to graph, because remember, we were supposed to graph the fraction, right? And notice that there is also the main. Whenever you have a denominator, there's a question about its domain, or making sure the denominator is not equal to 0, so x is not equal to number 1. So actually at point 1, we don't have value of 2, because x cannot be equal to 1, which means that we have a hole on the graph. That's interesting, right? So there's a graph of line, but with a point pinched out, because it looks like we cannot have our denominator equal to 0, so 1 is out. So that point has to be thrown away. That's worth to think of. So in the next group of exercises in this section, they talking about the other type of story that we also saw back in college algebra class. So let me try to do some problems here in the next page. Like, for example, if you try to work out exercise number 37 that wants you to solve equation. So again, that's a refresher of what you hopefully already know. If not, that's okay. You can just learn it right now. So we solve equation here. And the way to solve this equation is to produce a 0 on one side. So you write x squared minus 2x, and then minus 2 is equal to 0, just like we did for the quiz. So we can factor this with a 2 and 1, but that's not going to work, right? So what we need to do is use so-called quadratic formula. Remember, if we have an equation with square, so people say in general it's a times x squared plus b times x, and then plus c is equal to 0, then the solutions of this equation, the values of x, will be coming from the special fraction with a 2 times b in denominator, 2a in the denominator. Remember that formula with so-called discriminant, negative b plus minus square root from b squared minus 4 times ac, right? So that's a so-called quadratic formula to solve equations in a case if you can't factor. In other words, you need to identify your a, b, and a c, and once you identify those, you'll get the numbers to plug into your equation. Like here, we have x squared, so it's just 1 multiplied by x. B is number multiplied just by x term, that's negative 2, and finally c is also negative 2. So now I'm going to use the formula down below this fraction. So I'm going to just replace in it minus b, so it'll be minus 2, because I need to take negative of that, right? And then a square root from minus 2 squared, b squared, minus 4 times a times c. So 4 times 1, that's a, and c is negative 2. So here I have this fraction, and denominator is 2 times 1, 2 times a. So now you need to simplify and get the answer, right? So it's going to be 2 plus minus. Now let's see what we're trying to square root in here. It's going to be 4 plus 4 times 2 is 8. So it's going to be a square root from 12. Well, no wonder we couldn't really solve this, because this, well, expression is hard to solve because you cannot really factor it, right? So this is our answer to the exercise. So you could just leave it like that. I know that sometimes people like to simplify it. You can write this 12 as 4 times 3. So you can actually have a numerator that has split into 2 fractions. And then there'll be a square root 4, which is 2 multiplied by radical 3, because if you split this in 2 fractions, then you can cancel your denominator and have 1 plus minus a square root from 3. So there are actually answers such as a 1 plus radical 3. That's the first one, and the other is 1 minus radical 3. That's the second answer. But again, I'm not asking you to do all that. That's really going deeply into algebra. So for the answer, if you just leave it as a fraction, that'd be good enough. But I think it's also interesting to know that you can actually solve this and find simpler result. So it looks like problems in this group of exercises, they all ask for using quadratic formula. So I can try one more, like number 45. that has denominator of x, so they recommend to multiply by that denominator every term of this equation and the left and the right side. So the reason they want to do it is because they want to cancel out x. So let's see what we're going to have now here. The exercise 45. We're dealing with x squared plus 7 times x and plus 9, right? And notice that again, you cannot really factor number 9, so you produce 7 in the middle. So once again, you need to identify your A, B, and C. So that'd be a little bit tedious, right? To use this quadratic formula every time. But I just want you to be a little bit familiar with it because who knows, we might use it every once in a while in the future. So negative B, right? So again, I'm looking at this formula down below here on the right. So minus 7 plus minus. Now I put a square root from 7 to the second power minus 4 times A times C. So it's 4 times 1 times 9, right? And divided by 2A, which is divided by 2 times 1. So once you calculate this discriminant, which is going to be 49 minus 4 times 9, which is 36, then you can just write down this fraction as your answer. So it'll be minus 7 plus minus a square root I extract from what, 13, and then divided this by 2. So that's the result, and that's it. So we solve this quadratic equation by using the formula. So other things here in the section deal with the formula that says a square root from x squared is equal to just x. So that's the idea of this group of exercises. So if you have a, for example, a square root from x cubed, then what you can do is write this. So exercise 47. You can write this with a fraction or ratio. So it'll be power of 1/3. Did you know that? Power of 1/3. And there is a formula that actually being used for this. So let us recollect what formula there was. So I'm gonna get some room here. So dealing with so-called radicals, turns out it's convenient to write them as powers. So if you have, for example, nth root of x raised to the power of m, then you write this as x raised to the power of m is a numerator, but nth root is a denominator. Like here we had a cube root with exercise 47, then the power of 3 went in denominator. So that's the idea. So if I have, for example, problem number 51, then t will be raised to the power of 1/7, just like that. And of course, you can go backwards, like in the problem 59, you can write x raised to the power of, instead of 1/5, actually put the 5th root extracted from x. So you can either write this as a power, or you can write that fractional power back as a radical. So it depends on the exercise. So if I try to do number 62, then we have a square root extracted from t raised to the power of 5. Notice for a square root, we don't put the 2 here because automatically radical means square root. And of course, that's good to realize. So how about exercise number 54 that says take care of the cube root of t to the power of 6. Well, I'm gonna write this as a 6 divided by 3, right? Because cube root means 3 goes to denominator. And that actually simplifies expression. It gives us t raised to the power of 2, which is pretty nice, right? Again, I'm utilizing this formula for the nth root, so n goes down to denominator. Well, there is another formula that you probably saw in the previous classes. That formula says that if you have a negative power, then it's 1 over x raised to the power of positive. So I'm talking about exercise like 56 here. That wants me to deal with the power of, looks like square root from m in denominator. And I can rewrite this as a 1 over x raised to what power? 4 is on the top. Well, that's not x, that's m, right? So I should be careful. It's m. So m will be raised to the power of 4 is on the top, and the 2, because it's square root, is on the bottom, right? So it's be 1 over m squared in denominator. And sometimes people can write this as m raised to the power of -2 using the formula that brings this to numerator. But again, it's just good to know, but whether you leave the answer as 1 over m squared or m to the negative power doesn't matter because they're same, and that's good to realize. So how about if you try one exercise? I just saw one nice exercise, problem number 53, as a little quiz for today. So look at how I did the previous 2 problems. It's very, very similar. And all you need is to, I guess, use the formula for the radical to rewrite it as a fractional power. And once you're done with it, you will get a very nice answer that will, I'm sure, make lots of people very happy. So as usual, just send the answer for a quiz only to my name. Don't send it to the whole class. So don't hurry. You have plenty of time. So just do the little quiz, and after that you can log out and have a wonderful day. So we'll continue on Wednesday. On Wednesday, I will be on campus. So if you like, you can come to the classroom, or if you don't like, then you can stay in your place, because I usually let my students do quizzes by Zoom if they want to. So it's your decision. So don't forget to answer quiz. Exercise number 53 is here. And don't hurry, you got plenty of time for that.